Hello, welcome to another edition of House Modeling in 3ds Max tutorial. In the last episode, we modeled these black plastic tanks. In this episode, I'll be working on the plumbing fittings. Yes, the elbow, the T, the pipes, and what have you. So I'm coming to File, Import Merge. All okay. Auto rename, apply to all, duplicate, auto rename, close. Now these are the things I'm working with. This is the T, this is the pipe itself, this is the 1-inch pipe, this is the elbow, this is the tap. Now I'm going to show you briefly how I made this. This is just 3 cylinders, right? Say you have the cylinder this way. Let's rotate it 90 degrees. No, let's, yeah. Then so this comes down this way. Then just make it 2. And then this one convert to editable poly, then IDON selected, top, select the polygon, then you bring this in, you can see, and then you select the bottom view, select the polygon, this, and then you bring it in. So F, you can see on hide all. So that's how I created this. And then you just increase the size accordingly, something like this. You can see. That's how I created this. Then this is just one cylinder. This is a cylinder. This red is also a cylinder. Now this one is a box. Let me show you another view. L view. Let me see if I can show you the L view. Yes, it's a box. This is how I did it. Let's say 3 segments. The length segment, the width segments, the height segment, edge faces. So right click, editable poly. Then I brought this in this way. This way. You can see. Then I take this to the middle and this down. That's how I create the top of the tap. Then you can go on to chamfer the edges. You know, you just come here, click the edge, you go to chamfer. Alright, type in values. Alright, that's how I did it. I just chamfered all the edges and I got the tap head. That's how I created this. And what else do we have here? There's the elbow. I used line for this. Let me go to from standard primitives. Let's go to sorry, I keep forgetting where line is. Oh, sorry, standard primitives here. Yes, on this section, shapes, line. So this way, and this way, something like that. Sorry, yep. So you have the line. Now it is to achieve a perfect elbow, the distance from here to here should be the same distance as from here to here. So now how would I go about it? This is how I would do it. I'll say draw a box. Alright, let me see, maybe if I change it to clay. Yeah, so this box, the length of this point to this point, that's the box. So I'm going to rotate the box, sorry, 90 this way. Then I bring this, you see, then I take this vertex, this particular vertex, then I bring it down. Now you can see. So now it simply means that the distance from here to here is the same as the distance from here to here. Now, to be sure that your vertex is perfect, your line is a perfect L, this is how I would go about it. I'll take the values here, the X values here. I'll come to the X, Control A, Control C, then I come here, then I do Control A, Control V, enter. Now they're perfect. Then this way too, I come here again, I'm going to copy the Z values, Control A, Control C, then I come here, go to the Z, Control A, Control V, enter. Now you have a perfect L. So what's the next thing? You're going to click this vertex, this one, and then you come to fillet. Yes, and then you come to rendering, and then you increase the size, and you come here, enable in renderer, enable in viewport. Now, as you're increasing the size, you're getting the tube. That's it. You're getting a tube. That's how you get a tube. Alright, and that's how you create your elbow. It's pretty simple, pretty straightforward. Now, this above the elbow is just the cylinder. If you see a real life plumbing elbow, you see that this is always there. It's because this is the point at which the pipe meets the elbow. This edges are made rigid. So this is just a cylinder. You just draw a cylinder on it like this. Let's rotate the cylinder 90 degrees. Oh, sorry, not that 90. Okay, let's turn this to 0. Let's turn this to 0. Yep. So you bring it down like this. And then you make, yes, something like that. Then you reduce the radius accordingly. Make sure it sits perfectly. That's it. Now, in real life situations, these things would be hollow for water to pass through. But this is a 3D design. We don't have to work on the interior at all. On the insides. We don't have to work on the insides of this object because whoever you're designing for will not see it. So we don't have to make the insides hollow. In other situations, if you needed to, maybe in product design, you might have to make it hollow. But right now, we just need it to fit nicely into our drawing, so the insides don't have to be hollow. So let's go back to default shading, so I can delete this. And this one is just a 9-foot pipe, a 9-foot tall pipe. And this is also a 1.5-foot tall pipe. It's just a cylinder, nothing big deal. Just draw a cylinder and give it the height you want. Now, how did I get the thickness of my cylinder? I know that a 1-inch pipe, you'll have to Google, a 1-inch pipe has 0.9, the nominal value is 1 inch. But in actual size, the outer wall, a pipe has the inner wall and then the outer wall. But we're not concerned about the inner wall now because we're not showing the inside of the pipe. So we're only concerned about the outer wall. And the outer wall is 0.97 inches in diameter. 0.97 inches in diameter. So to get the value in feet, since I am working with feet, then I come to calculator. 0.97 inches. Sorry, 0.93. I beg your pardon. It should be 0.93. 0.93 inches divided by 12. So this pipe has a diameter of 0.07. A diameter of 0.07. So the radius would have to be half of that. And that's how you get the value I have here. The radius would just be this divided by 2. And then you get the radius. And then you type the values here. And then you work with that. So let's take this elements to... Let's go to the tank. So let's go to back view. Back view. I want to put a cylinder here. I want to create the inlet of the pipe. L for left view. Back view. So let's give it the black color. Yeah, it's not visible, it's just I think it's too big. Yes, something like that. It's not visible, like I said. So let's start working on the pipes. There they are. F for front. The first thing I need, I think, is yeah, I'm going to need this and this. I'm duplicating, shift and drag. Top view. Let's group it. Let's rotate 90 degrees. L. Let me be sure what I have is 1 inch. I beg your pardon. Let me just be sure. So let me draw a 1 inch box. And the value of 1 inch, 1 divided by 12, 0.08. So I'm going to give this the value 0.08 times 0.08 times 0.08. Good. So what I have just noticed right now is that this is how thick my pipe should be. So this is bigger than it really should be. Yes, this is what it should be. So let me hide this and delete this, then unhide all. Then top view, I want to see if it aligns. It doesn't align yet. I move this way. Yes, then F. Let me move all this upwards. Top view. So this pipe, shift and drag. I'm duplicating. Hell. It's going up there. Zero. This is also, like I said, because that is bigger, this is also bigger. So now I have to make it smaller. Drop the values. I think when I was designing it, I must have made a mistake. I thought I was working with inches. So this is going here. Sorry. Yes. It's still going to be a bit larger. Yeah, something like that. And then take it to the back. Top view. Yes, so now as you can see, let me move to the camera so we can see what we've done so far. Let me take away the edge faces. On checking edge faces, so this is what we have done so far. You can see. That's it. So now this should naturally extend beyond this so that the elbow can come in and then it goes straight down. We're still working on the inlet. Top view. So it has extended beyond this one. So it's just going straight down now. So now we need the elbow. This is the elbow. Duplicate. Sorry. Hold shift, drag. Duplicate. Press L button. Drag it up. Rotate 90 here. Alright, let's do 180 this way. Oh no, sorry. 180. Let's do 90 this way. Okay, so we're good. This is also larger than it should be. So now we're going to reduce the size. Yes, it's meant to be something like that. Top view. Dash to align. Yes, there you go. Top view, L. Now this pipe, take it this way. Going to rotate it 90 degrees. Oh, or take this 90, turn it to 0. Yes, good. Then this way. Now in Nigeria, these pipes come at 9 feet. I don't know the height they come in other parts of the world, but in Nigeria they come as 9 feet. So I've not made it an editable poly yet. It's still a cylinder, as you can see over here. So I'm just going to height, and I'm going to make it 9 feet. 9 feet. Then I drag it down. It's going down. It's going down. It's going. You just can't see it. All right, let me just zoom out. It's going down. Down. Yes. And then it goes in just a little. Yes, something like that. Well, let's take it inside some more. But if you take it like this, now I think the elbow has to be a little larger. Yes. Okay. So top view again, just to be sure that the elbow has not been misaligned. All right. So this is 9 feet L. So that's a 9-foot pipe going downwards. Now let's take this dude. Let's duplicate it. It's going to act as our joiner. Let's ungroup it, group on group. Then we're going to take, we're going to take this guy and duplicate it. You can see. So now I have this grouped. So let's rotate this 90 degrees. Yes. And bring it here. This is going to be our joiner. Top view. just to be sure it's where it should be. Yeah, it looks like it's where it should be. Hell view L again. Then we take this pipe, the 9-foot pipe, and it goes down again. It's coming here. Yeah, there you have it. That's a 9-foot pipe. We've not worked on the second tank yet. This is still the very first. So that's 9 feet. So we take the elbow again, bring it down. Sorry, the joiner. I'm sure there's a name for it. This way. Then the 9-foot again. It keeps going down. Keeps going down. Yeah. So let's go to the back and see how far we've come. I'm hiding the fence, hide selection. Okay, so we stopped here. Okay, we can still go one more. So joiner now. Let's take the pipe. I'm duplicating again, shift and drag. And it's going, and there you have it. I think this last one should go, yes. It's almost where it should be. Okay, now we're going to have to break this. L. Left view, L. Let's hide this. Okay, this is where it ends. Naturally, it's going into the ground. I beg your pardon, because for a clean job, you're supposed to do your plumbing before you tile your compound. So this is assumed to be going underground, but we're going to have to break it some point. So let's make the height now, instead of 9 feet, let's make it 4.5. 4.5, yes. So we're taking it up. I'm going to show you why in a second. Now we have to introduce the tap. Let's go to the back view. This 4 elements, this 6 elements, 1, 2, 3, 4, 5, 6, they make up the tap. Group, call it TAP. Alright, so L, bring it here and rotate 90 degrees. Oh, sorry, let's do 270. Alrighty, and there is our tap. Now it's also bigger. You remember we changed the sizes of the elbow and the joiner, so now we're going to change the size too. So there's the tap. If you still need clarifications on how I drew the tap, I'll explain, but I think I explained in the early part of the video. But if you still need insights, let me know. I'll let you know that. I'll teach you that. Back view, click on that. It's not where it should be yet. What's this? Okay, let's hide this. Alright, so we can see properly. Now it's too small. Yeah, it's more like that. Hell view. Let's hide this. Yes, there's the tap. So now the rest of the pipe can now go underground. And this can just be made to be 5 feet. And then let's just drag it down a little. And it goes underground. That's laying the inlet pipe for the tank above. Now for the second tank, let's take this tiny thing that I drew at the very beginning, and I'm bringing it down. I'm duplicating it, shift and drag. Yeah, duplicating it. That serves as the inlet. So we're just going to repeat this. All right. We're going to, let's group. Okay, and shift and drag. Now you see, now in real life situation, they would not be like this. You can see they're clashing with one another. So what you want to do is you rotate it, you group this with the tank. So I take this, I take this, I take the tank now, I group everything, turn them to make them one. Then I can click the rotate button and just rotate a bit, and then move a bit. You can see what I have done there. So this can come in separately. That's how it should be in real life situation. You can't have both of them clashing, because the idea of this is, if I need to fetch the topmost tank, there should be a tap for it. If I need to fetch the one at the bottom, there should be a separate tap. So if you had just one pipe, then the problem is when the bottom tank is full, instead of water coming to the top tank, to the tank at the topmost level, then it will just be wasting at the bottom level. So you need two separate inlets. Two separate inlets. That's a real life situation. So you can bring them quite close, but they cannot clash. So hell, now we start laying a similar piping like this 9-foot pipe. We now take it down again. We are duplicating. It's coming down. Let's go to the back view. Back view. It's coming here now. You can see. It's coming right here. So let's just hide on selector. Let's see. Hell. Yes. It's going to be here. On hide all. Back view. So the pipes are close, but they are separate. Now we need another joiner. Shift and drag to duplicate. Hell. Okay, the one in front is clashing, so let's go back to the back view. Hide unselected. So let's do L now. Yes. So it's where it should be. Then take this pipe again. Did I take the pipe? No, I think I selected the wrong thing. Yes, I'm selecting the pipe now. Shift and drag. Okay. So one more. Shift and drag. Bring it down. Now let's unhide all. Let's go to the back view. Let's hide this. Are we there yet? Let's hide this. Okay, so we're there. Now we're going to reduce the height of this one. Let's call it 0.5 feet. Let's take it up. You can see. Okay, we can increase the height a bit. Just a little. And then we take the tap here. We're going to duplicate the tap. Sorry, shift, drag, duplicate the tap, and then let this continue duplicate. And then let's call this 5 feet and bring it down. Still coming down. And there you have it. So these two on idle, on idle C. So now you have inlet pipes for both tanks. You can see this is one, and then when I go this way, that's the second one, and then the taps are down there. They go into the ground. So now we need to create an outlet pipe that will connect both. They both serve one apartment because it's a duplex, it's just one house. So now we're going to create a pipe that will come out from here and go straight down. So let's begin. Let's ungroup this. Let me take this, duplicate it, rotate 270. Yep. Front view. So I'll be sure it's where I need it to be. It's going up a little. Yes, the hell view. Then I take this pipe, this short pipe, shift and drag. Front view again to be sure it's where it should be. Yeah, it kind of is. Okay, L. Now we need a T. I think we have a T here. No, sorry. Back view. I think we have a T somewhere. I designed a T. Yes, this is a T. Okay, 1, 2, 3, 4, 5. This 5 form a T. Group. Let's call it the T joint. Yeah, that's my T joint. So we can delete this now. We can delete this. We can delete this. We just need a T joint. So the L for the left view. So the T is going here. Now we have not resized the T. Like I said, I noticed that when I brought all of them in, they were bigger than they should have. So now we're reducing the size of the T. If you don't know how I drew the T, please watch the early part of the video. They're just cylinders. Cylinder 1, cylinder 2, cylinder 3, cylinder 4, cylinder 5. That's it. There's no holo because, like I said, we're not focusing on the inside. So there was really no point having a holo joint. Sorry, having a holo T or a holo elbow. F view, F for front view. So this is coming this way. That's a T, and it's going to be somewhere here. Good. L view again. So this guy, this pipe, shift and drag, duplicate. I'm going to rotate 90 degrees. Sorry, I think I'm going to turn 90 here to 0. Yes. So I'm bringing it here. Now, it's possible you have what we call a ball float. And the job of a ball float is to, just like you would have in a WC, is to, what's the word? Stop your tank from overfilling. But if you have a ball float in the plumbing, in an electrical plumbing system, then you should have something that cuts off power to your electric pump, whether it's a surface pump or an underground pump. But in this case, I'm assuming, all right, that it's a surface pump and you don't have a pump control. So what is quite common in this part of the world is that When the tank overflows, you get the spill, and when you hear the tank spill, you go and turn off the pump. The water will splash on the floor, and then you know, oh, it's full. Then you go and turn off your pump. So what you will do now is I'll give this pipe, let's say 8. Yes, it would be like that. If it's too tall, let's say 7. Yes, it just needs to be slightly taller or about the same height as a tank. And so what happens is, as water is filling up here, as water is filling up in this tank, it will match the level in this pipe. As it is filling up, you know, water is coming from here, right? Yes, from this place. As it is filling up here, filling up here, filling up here. So when water gets to this level, it gets to this level in this pipe. So anything that will make the water over spill here, it will definitely spill here. So let's reduce this a little and say 6.8. 6.6. Yes. So it's still taller. Let's say 6.4. Yes. So now, when water gets to this level, it gets to this level. So water can easily spill from here. And when you hear the splash on the floor, you know water is full. But don't get me wrong, you can always have a more sophisticated system if you can afford it. So we're duplicating the pipe. Let's make it 9 feet. Let's see how far 9 will go. Yes, 9 can still work here. Let's drag it down. Are we there yet? No, we're not. So we need one more. We need to duplicate this T. Shift and drag. Oh no, let me just delete this and go and copy all of this. This. Group them together. Then shift and drag. Yes. So this will have one connector. This F view, front view, I mean. Yes, I think it's where it should be. Okay, then L. Sorry. Click the pipe, then drag it down. It is entered. Right click, convert to editable poly. Then I take the vertex, delete all of this. Then I bring this down here. Yeah, something like that. So let me take the 9 again. Drag. Yes. So let's hide this fence. Okay, where do we have the taps here? The tap is here. So we are still going to put one union. F view. Right click. Hide. Right click. Hide. Hell. Hide unselected. F. Okay, I just want to be sure it should be okay. On hide all. But I'm still going to hide this. Hide selection. Hide selection. L view. Hide selection. Hide selection. So take this again, bring it down. Let's call it 2 feet in height. Yes. Now the tap here, we're going to duplicate it, rotate it, say, let's say 90. Yes. So let's call this 3.5. So bring it down. And then we put a tap here. It's going to be a tap here. Front view. Oh, sorry. Let me hide the car. Yes, it's where it should be. Then L. Then let's take this and drag it down. And that will be the last. Right click, editable poly, vertex, vertices, and unhide all. And I think with that we should be done with plumbing. Now what have we done? Let's come here. So you see that when water comes from here, it goes down, it goes down, it goes down. Because they're serving the same apartments, they can connect to one another. It goes down, and into the house. Now there is something that should be here, right here. I think I'm just going to simulate it with, let me just put, sorry, let me take the tap. I'm going to explain it. Height selection, height selection, height selection. Okay, yes. Then I'm going to duplicate the tap. Hell view. Now, what I want to create here is what we call a no return valve. And what it does is it allows water to come out from this tank at the bottom, but water will not go into it. The only way water can enter this tank, the only way we want water to enter this tank is from here. But now that we have connected this and this, water naturally would want to enter through here and it would overfill. Because we don't want that to happen, we now have what we call, in this portion, we have what we call a no return valve. Now what a no return valve does is it allows water to come out from the tank and go down this way, but it stops water from coming in this way and into. So in real life situation, it looks kind of like this. Yes, it looks something like this. It can come as metal or plastic. It looks kind of like this. It stops. There's a valve inside. The valve goes only one way. It allows water to come from the tank and go out of the tank downwards, but it does not let water from the tank up there come in. That's the job. If you don't have a no return valve here, all right, then you're going to have issues. Rather than water going, every time water comes in from here, goes here, it will come out this way, it will go down this way and enter here. And you don't want that to happen. So you have to put a no return valve here. So I don't selected F. Yes, on hide all. So we are done with plumbing. That's plumbing. Using 1-inch pipe. Let's render. These are the colors that we have in Nigeria largely. Our pipes often come with this, I don't know if it's turquoise, this shade of blue, bluish green, and then our joiners come in dark gray, quite dark gray. So that's why I've decided to use these colors, because they make them relatable. Because Our focus as designers is to let the clients appreciate what we've drawn. All right, let the clients see this and say, "Oh wow, so my house will look like this when it's done." I mentioned in one of my earlier videos that I'm not an architect. I don't have a degree in architecture, but I design buildings. But before buildings like this would get approval here, you would still have to consult with an architect. An architect would have to go through everything we have drawn, give an okay, can tell us to modify. A structural engineer too would also look at the structural elements. I don't design structure per se. All right, I focus more on the aesthetics. All right, but because I've seen this often, all right, over the course of say 10, 15 years, I know the nominal sizes of the members, of the structural members, and I try to let the sizes reflect in what I draw. All right, but a building like this, a structural designer will still have to say, okay, this pillar should be here, should have this number of rebars, all right, should be this dimension, etc. So our job is to make the building appealing, but even at that, we try to follow the guidelines in building codes. So if you have questions, let me know. I'll be glad to answer. So I want to see if I can render this. It's going to take a while. All the other plumbings in the house will be embedded in the walls. The plumbing in the toilet, the kitchen, everything will be embedded in the wall, so they won't be visible. So this is the only plumbing that will be visible to the eyes. Every other one will be underground. Underground in the walls. The pipe that would carry the body waste down to the septic tank will be embedded in the walls, so you're not going to see all that. So this is what we created. Sorry, it's taken some time to render. My system is a 16 gig RAM, Core i7. So I think you understand. So if you have questions, these are the joiners. If you have questions, let me know, and I'll be glad to answer them. Thank you so much for watching, and God bless you.